So here is the smart contract code, mlm.solve. So here again the contract, the problem statement has been mentioned here. Now I am using the pragma solidity 0.5.0. Company, franchise and member have their own accounts. So according to the class diagram, the company, manager and franchise are having, company, member and franchise having their own account. So this is the contract account. This is the contract account. Address, payable, private, my address. To hold the owner of the account. And only the company's address should be public. As per the problem statement, company's address can be public. The reason is anyone wants to know the company details, then the either franchise or member or manager should be in a position to fetch the particular details. So the reason public, the one who is originating that smart contract should be, its address must be public. Otherwise, no one knows who started this contract. Other than that, remaining all address should be private in nature. So private, and here also the symbol what we have used is minus. Okay, minus means private, plus means public. Function external payable. It's a fallback function to make account automatically payable. Whenever you get the data, whenever you get deposit amount or withdraw amount, automatically whenever any function was called on this particular account contract, automatically they are payable. That related amount will be deducted from the user's account, the one who is operating that. Constructor, address, payable, address, public. So we are going to make note of the address of the person who initiated this contract. Next one is get balance, to view the balance, and to view the owner, get function, because we have seen set and get functions, get methods we have used in the definition, that is in the explanation of the functions. Like here, being functions like set function, get function, is function are used. Function get owner. Next, modifiers, check address validity, because anyone cannot access the address of account of another person. So the one who is operating is the same person or not, that we are going to see. So check address validity, check balance validity. So balance validity also, if the balance is greater than 0 or not, that we are going to see. The function transfer balance, check address validity, check balance validity. If anyone wants to transfer the balance, then they need to first check the address and balance validity. These are the modifiers. So in the class diagram also, we are going to use the modifiers. So these modifiers like check address validity and check balance validity. Now kill function. In order to kill the function, kill the contract, first we need to check whether message sender is equal to address or not. The one who is initiating this kill operation is the owner or not. Then go for the transfer balance. The transfer balance is like, first you need to check the address validity, then balance validity. If the balance is not greater than 0, then there is no need of sending the thing. If the balance validity is greater than 0, obviously the remaining amount will be sent back to the externally owned account, to whom it has to go self-destruct of address of this. Address of this means who owns this particular account contract. That account contract, account holder's address, externally owned account, to that account it has to go. So self-destruct of address of this. So this is the way of writing the account contract. After writing the account contract, now we'll move on to the multi-level marketing contract. So this is the main contract in which we have all these structures. Now, as Solidity does not support floating point operations such as the division, let us declare constants for the fee share according to the problem statement. Okay, because we don't have the function of floating point operations in ML, this Solidity. So we'll define it as constant, like franchise registration fee. It's a fixed one. So we'll make it as a constant. U int constant public franchise fee is equal to 500 Y. U int constant public membership fee 100 Y. Next is franchise share in the membership fee is 30%. That means if a member joined through other member, then 30% is the membership fee that franchise has to take. Remaining 70% to be given to the member. Next is U int constant group size is equal to 25. Maximum group size is 25. These are the constants. You cannot change these values. And if anyone want to know what is the franchise fee, membership fee, since these are the constants, you can make it as public so that anyone can view this. We have made a company, manager, franchise, member as the structures. Now, company structure holds details. Structure company, address, string name, string the postal address, that is city address, mapping, uint 32 to address. So that is pin code to the address of postcode manager. Okay, manager. This is the one-to-many relation. Mapping will be done here. Company to mapping. Next, mapping address to the Boolean manager list. Whether this manager is a valid manager under the company or not. So for that, mapping valid managers list. Mapping for available pin code list. Whether this pin code is serviceable under this company or not, to check that. Next is mapping for registration deposits address to amount deposited. So this is the mapping. So mapping from address to depositor pin code, the one who deposited, from which pin code he deposited that. Next one is mapping address to Boolean depositors list. Address depositor index. Mapping address to the address franchise manager. Mapping address to Boolean franchise list. So array of franchise addresses, franchise index, and account. So which account it is? This is the contract account. Okay. These are the things we are going to hold in the company structure. Because company can see the franchise details, company can see the manager list. So that reason company and franchise related mappings must be placed in the structure. Next one is structure to hold franchise details. Now franchise structure to be defined. Address approved by, to who was approved this franchise, that is the manager. Address of the manager who approved the franchise. Next is mapping of franchise member availability. So address to the Boolean, whether this franchise, whether a member is available in the franchise or not. Because there is one franchise may have maximum of 25 members. 1 to 25 members are there. So we are going to map it via this particular thing. Address member index. Since it is a association with one-to-many, so I told you that one-to-many relation will be represented in the arrays, and also this association can be mapped using map. Next is uint pin code, int size, group size, to keep track of the size. If any new member added, this size will be incremented by 1. How long it will be incremented? It will be incremented till the group size, maximum group size is reached. Again, the franchise is having its own account. So this is the account instance of the franchise. Like that, member is having the address, franchise address, and joined by who joined him. If he approaches directly to the franchise, then franchise address will be there. Otherwise, other members' address will be there. Again, member is also having his own account instance. This is the account instance. Now, other mappings. Now, data structures for holding the franchise details. Here, mapping address to the franchise. So, address to the franchise details. Next is pin code to the franchise and franchise list. Address private franchise index. Only company address is public, remaining and all are private. Data structure for holding member details and mapping for member and franchise. Company, private, company. Company is also, company structure is also private in nature. Only company address is public. Now the constructor starts. Constructor, string memory name, string memory C address public. Since I am using 0.5.0, here let will go for 0.5.0 and auto compile is enabled. Yeah, it was compiled successfully. Company, private company. Okay, this is the constructor. The one who created the contract, its address will be registered here. Company.addr is equal to, because the one who created the contract is the boss of that entire smart contract. So company.addr is equal to message.sender. MSG is the default object with which you can call the sender variable name, so that the one who will initiate, like for example, from here, if I say deploy, then from which account you are deploying this contract, that fellow will become the company. Company.account is equal to new account of msg.sender. Now I have created account instantiation, because the one who is creating this contract, MLM contract, will be having address, and that address is passed. That address is passed into this account constructor. Now when you are killing this account, to whom they need to, this particular remaining balance will be sent. You look at self destruct of address of this, the address that is injected at the time of construction. To that address, this leftover balance will be sent back. Next, modifier to validate company address only by company. This you are aware of how to write the modifier. We require message.sender is equal to company.address. Next is function to check availability for manager corresponding pin code, to check whether the manager is available or not, whether he is the manager or not, he is the manager for the corresponding pin code or not. That is, his manager was overloaded with the address and uint32 pin code. By supplying the address and also by supplying the pin code, we are going to check whether the manager is there or not. Get company address, get and set methods. Get manager address, change manager. This is the update manager, because this is the offline activity. So whenever company updates the manager data, then updating the manager information. This is the on-chain activity. So change manager. This is the details. This will be done only by company. This will be done only by company. Next function, recruit manager. So here recruit manager, whenever the recruitment is over and when they are entering into the database, address of the manager is required and pin code is required. That those two parameters will be supplied to this recruit manager function, and that will be done only by company. That means during the whenever it is supplying, only the company representative has to log in, the one who created that contract, and with that only this recruitment of the manager will happen. If already for the pin code manager is available, then revert the operation, otherwise enter the details. Modifier to check franchise fee. Modifier check franchise fee, that is whether the franchise fee has been deposited or not. Require message.value. How we will supply message.value? When you are writing the function, here value is there, right? This value you are supposed to enter. Here you are supposed to enter 500 and you have to click that deploy. Okay, you have to call the function. You can also see these are the four denominations by default they have provided: Ether, Fini, GWI and Y. These are the four denominations they have mentioned. We are using Y here. You may also use other denominations depending upon the problem statement. Like that, modifier for availability of manager for a given pin code. function to apply for franchise in the given pin code. Apply for franchise. Whenever the front end is updated, then automatically this apply franchises should also be called, and this should also be updated. And is valid manager, this is also a modifier. Check deposit, this is also modifier. Whether the corresponding franchise applicant has deposited the fee or not. This so many modifiers will be there. Okay, especially to not to engage any function into the faulty operation, we use so many modifiers like this. Check franchise is another modifier. Approve franchise. So this approve franchise is again, they will check whether deposited is amount has been deposited or not, and whether the franchise is available or not. By all these things, if he is a valid manager, to approve the franchise. Okay, he is valid manager, check deposit, check franchise. If these three conditions are true, then the approving will take place. Once the approval is taken place, then these particular details, franchise details, need to be entered into the franchise data structure. Once after entering into the franchise data structure, then that need to be pushed into the franchise index. This is the franchise index dot push of the corresponding address. Now function get registration balance public only by company. So this is the get function. Get franchise by pin code. This is also get function. Franchise size. Next is transfer registration balance. Check membership fee. This is the modifier. By valid franchise modifier. By valid member modifier. Next is valid franchise. This is also a Boolean function. Is valid member. These are the Boolean functions. These are all the helping functions for running the main functions like apply membership. In order to apply membership, first you have to check the membership fee. Checking the membership fee modifier is there. Automatically membership fee will be checked. Once the membership fee is checked, then is valid franchise to whom you are applying, and get franchise size. Already the franchise size is less than 25 or not, you check it. If it is so, then go for creating of the address, creating of the member, and that member will be added to the members list. Otherwise, if the valid member of F address and get franchise size is less than this one, then that is the membership can be done in two ways: via franchise or via some other member who is belong to the same group. So you have to check two conditions. First, if the member is directly approaching the franchise and getting the membership, it's fine. The first statement will execute. First block will be executed. If he is coming via other member, then second block will be executed. Okay. So this is the way. The procedure is same again. The corresponding thing. The only difference is the amount that will be deducted towards the membership share, that will differ. Anyhow, we have used the constant of 30% and 70%. Directly we use that particular value, and that amount will be deposited into the account. If not these, if the membership fee is not proper, then revert the operation so that nothing will be recorded onto the chain. Next is get account balance. This is also a get function to check the account balance of corresponding address. And function to the transfer balance. This is the function to transfer balance. Company.franchise list message.sender, and to whom you want to transfer the balance. So this is dot account. These are the default functions that default variables that you will get via this thing. Transfer balance, because transfer balance is a function which is already there in the account. Next is kill membership function. Kill membership public by valid member. If it is a member, then member. Then if it is a franchise. If company. That checking will be done here. This entire function. Next is kill franchise. This is the function related to the checking of the killing of the function. Killing of the franchise and killing of the contract. Function kill public only by company. Before killing, first you are supposed to transfer the balance, then kill the account. and self-destruct of msg.sender. So this is the code, and this code will execute, run and execute. So for that, you may also try it first. I will give it to you. You may also try it, and how to run it and execute that we'll see in the next lecture. Anyhow, I will provide you this code. You may go through this code and try to do some research on this code, and you may develop on your own. The main thing we are supposed to do here is the data structures need to be designed carefully, and modifiers and helping functions. In this, the main functions are transfer balance and apply for the franchise, and approve the franchise, apply for the membership, approve the membership. These are the functions. But in order to run those functions, so many conditions need to be checked first because of the security constraints. So you have to design the modifiers, security constraints, then functions. So that you are supposed to be very careful in doing that. Then only your program will be executed.